So I did want to address that question about types working in Documenter, because my talk is about Documenter, and specifically how you do crazy shit with it. And so the thing with types integration, right, is that the way Documenter works is that it's a Markdown to Markdown pipeline, and the parser and the AST structures that it works on are Markdown. Could you create a parser that parses types and gets it into the AST? Yes. I don't think that would be particularly easy to do because the types, I don't know what the types representations of things like code blocks look like, right, for example. Now, getting Documenter to output to types, it would actually be not so difficult to do. And so I'll show sort of how you do it. But yeah, just let me know when I should start. Or if anyone has any other random questions, I mean, we have a couple of minutes, so. Actually, just out of curiosity, how similar would you say like the types syntax AST is to Markdown? Like not the syntax itself, but like the structure of the document and the AST representation. Oh, sorry, didn't mean to make you run there.
Structurally, I think there's similar elements if you're staying within Markdown mode, but I think it diverges quickly, and the internal representation is very different.
Yeah. Well, I mean more the structure of the document, right? So like in that you have a header, and then you have some text, and then you have some like random like code or elements or whatever, right? But like, I'm guessing they're all kind of similar LaTeX types, like just the structure of the document. Like, you don't do crazy stuff with HTML or like HTML does or something, for example.
You can.
Oh no.
Yeah, it is more complex. It's a full scripting language in it. Wants to have feature parity with LaTeX, other powerful editors.
Yeah. Okay, interesting.
All right, so now it's officially time to start. So again, last session of the block, we have Anshul talking about Documenter.jl.
Yeah, hi. So I now work at Julia Hub. I'm also one of the authors of DocumenterVPress.jl. You guys may have seen that. Did a bit of work on Documenter, a lot of work on Markdown.jl, so that's the sort of primary open source thing that I do. But yeah, today I just wanted to sort of demystify a bit how Documenter.jl actually works, because it's a very powerful tool that I don't see people using its power that much. And I've done some crazy stuff with it recently, so I thought it would be a nice opportunity to just show how you can do that too. So first, what is Documenter, right? Documenter is a documentation for Julia. It takes in Markdown input, and it can give you back, by default, HTML or LaTeX. With some external libraries, it can give you Markdown output too. But that's not the whole story. The whole story is that this is a Markdown-based processing system. So what do I mean by that? I mean that it reads in Markdown files, right? And so I have a little demo thing here. This is kind of too zoomed in. Is this good? Yeah, all right. People can read this text mostly? Okay, sweet. Yeah, so you know, this is your classic docs directory, right? You have a make.jl, which you have some make.docs call, right? And a lot of this is kind of magical, but implicitly it will assume that your source folder has some Markdown files. And you know, you can have some Markdown files, right? And you know, maybe we can have a file that has some problems, right? In here, you'll note that I have not closed this triple backtick. And what it will do is it will load these in, it will parse them, and so doc.user.pages. Oh, did I not run this in this session? I guess I didn't. My bad. Well, it'll run at some point. But what it'll do is it will parse the pages. And okay, so you're all familiar with this, right? This is sort of the the standard thing you see whenever you run Documenter. Oh, it's running through all of these things. It's setting up the build directory. It's running doc tests. It's expanding templates. But what all this stuff actually does is it manipulates a Markdown abstract syntax tree that's held in memory. And so if I look at doc.blueprint.pages, only... Oh, okay, that's just a spec. Never mind. Doc. Where did that go? You can tell that this is sort of on the fly. I'll find it at some point. But basically, if I print out this doc, you will see this thing, right? Specifically this thing. And so you see that, there you go. So it's this dict. And so this is the home page, right? And so it's automatically picked up the header, and it said, okay, the file is build/index.md, or that's where the file gets built to. And what you have in there is this Markdown ast.jl abstract syntax tree. And so in this case, it's just got a single heading, right? It says Markdown ast.heading level 1. And within that, it's got this text element. But this can be nested arbitrarily, right? You can have text inside of which you have links, or you can have a paragraph. You can also define your own nodes. And so this is what I mean. It's a very flexible system. This is what I mean by the abstract syntax tree, the Markdown-based processing, right? And so why would you want to hack this? What could you possibly do that Documenter does not already do for you? It turns out you can do a lot. So one example is example galleries. So I have this in JuliaCon, which is another package that I do. This is also Documenter.jl, so that the thing looks slightly different. But by the power of modern web technology, I'm going to zoom in. And so you can see that, okay, this has got this... if you're familiar with democards.jl, this is very similar. You've got these examples. It pops up some stuff. This is all HTML, right? The real trick is in writing the examples itself, because the idea is you want to make this as easy to use as possible. So if I go to the GitHub repo, which I can't actually reach from here, there we go. I have this examples folder, right? And in that, I just have these literary.jl files, which have these little code blocks which actually execute inside the same process that runs all of this. And so the cool thing with this is, the reason I built this is because I saw democards. Democards is great, right? It's got a lot of cool features. It does Jupyter notebooks and all that stuff. But I saw democards and I said, hey, I don't want to save stuff to files. That's like so annoying. And so how can I not save stuff to files? How can I do this manipulation programmatically such that if I say that there is a cover image, right, I can just pass a marquee figure, I can pass a plots.plot, I can pass anything I want. And you can multiple dispatch on this package that I've written and make it such that whatever you pass here can be translated to an image, right? And so you can do that. And then what this also does is it says, hey, you've got a cover. Let me inject that right here. So it injects that into the Markdown syntax tree while Documenter is processing this. And then when it writes it out, right, you'll note I never included this figure. I never said anything about this thing. But because I wrote this extension, which automatically added this here, I don't have to worry about like a nice preview image for my blog post. So that's one thing. The other cool thing, okay, so look at this, right? This has I think I might have added those explicitly to everything actually. But I could also remove this title, right? I could remove this completely. And what it would do is it would say, okay, let me find the first H1. Let me find the first top level heading. That's my title. Right? And so you can do all of this programmatic processing inside Documenter and make your life just so much easier. So that's one thing that you might want to hack it, right? Another thing that I did recently for Julia Hub is we created this new language called Dyad, right, for modeling, and said, okay, we want to document this thing. But the way that the Dyad language works is that you write some Dyad files into a package structure, and then you run the Dyad compiler on that, which will transpile them to Julia code, right? And so then you load that Julia code into a module, and then you have those available as modeling toolkit models, right? And so all of this to say that these things, this dyad code has a very different way to run it than the Julia code does. But they both have to be integrated, right? The dyad code has to feed into this example block. And so the way I do this, which I'll go over, unfortunately that repo is not public, but I can show it to you on the video, so I'll do that. But the way we do this is we literally just created a documented processing pipeline that goes into a page, takes all dyad blocks, compiles them, and then into every example block, it injects a using statement, right? And it hides that from the user. And so I can just write this, it will just work. But if you look at the code that actually gets executed, it's got these things which are programmatically added into it. Another thing, so maybe I can click on this. Yeah, okay, so this is live, right? And so I kind of just edited the HTML here to make it nice to show on a slide. But here you go, right? You have this analysis world, and you can see that VitePress has this nice feature. It'll show you the language name. But here's your model, right? And here's this thing called an analysis, which you're running on it. And then in Julia, we show that you can just literally do using plots, plot result. But this is implicitly using the package that was generated by these. And so that's all in a Documenter pipeline. You don't have to think about it. You don't have to worry about it. You just have to write your example, right? And so what I was talking about with this example thing in Geomarchy was the dynamic rewriting at build time, right? So it fetches in-memory objects. It can use them, do whatever it wants with them, really. It can rewrite any aspect of your page if it wants to. And so how it works, as I showed, this is sort of an example from Markdown.jl. You just have this tree of Markdown syntax, right? And this is sort of a flattened view, but yeah, I mean, this is sort of how it works. So let's say, for example, that you wanted to mutate a Markdown AST. This is a super simple way to do it, and I'll actually run this in a bit. But basically what you do is you can do markdown.parse. There's a typo here, whoops. But you can do markdown.parse, right? That gives you a markdown.md object from the Markdown standard library. You can convert that to a markdown AST.jl node. And once you've converted that, this is then completely compatible with abstracttrees.jl. And so you can just run a depth-first search. If any node you encounter is a link node, you rewrite the link, right? If, for another example, we had some malformed SVGs being generated, right? If you go through the Markdown, which is of course parsing as Markdown, and it's not parsing as XML, right? That whole thing is just one paragraph block. If you go through the Markdown and you see, hey, this is a malformed SVG, delete it. It's gone. And notify the user and all that, right? So I show this just to show how you can use Markdown AST. This is not to say that you have to run markdown.parse on every page that you have, right? Documenter does that for you. It has a lot of hooks by which you can hook into the system. And it's a pretty flexible pipeline. So instead of writing up random slides about it, I will just show you the code. Is this sort of visible? Perfect. So this is the cool stuff, right? So you'll notice these names look very familiar. Set up build directory, doc test, expand templates, check document, right? And so what all of these are these are stages in a pipeline. And this pipeline is what Documenter runs from start to end. So initially, it will set up your build directory, right? It will run doc tests. This is the magic. This is where the magic happens with example blocks, with your page at meta blocks, right? With your setups. This is where the magic happens, is expand templates. Because in there, what it will do is it will search for any markdown that looks like this, right? That matches some criteria that you as the user can define. It doesn't have to start with an add. It doesn't have to be a code block. It can be whatever you want. But it will use its own matching engine to go and find these things. And then it will provide them to you in a function that you can just, you define a subtype, and you can just write your dispatch of that function and perform whatever manipulation you'd like, right? So another stage here, it finds each atref, and it goes and finds the correct cross-reference, and it sets that link, right? This is like the the very, very complicated version of that little link rewriting script I showed you guys earlier. Then this thing will populate the tables of contents and the indices with links. This render document is sort of where you write that Markdown AST to some file, right? Whether that be HTML, LaTeX, could be typed. I wrote a library I rewrote the library that sort of bit rotted that does it in Markdown, so I still have to merge that PR. But so basically, how this works, how you set this up, is you define, you create your abstract type, right? That subtypes document a pipeline, and you define when it should run, and this is a floating point number. But so let's say that you had some processing pipeline that you want to run before you expand your templates, before you call your example blocks, right? This is the case for that dyad thing I showed you, because you have to actually load the Julia library, so that actually has to exist. Just define it as just define the order as 1.9, right? If you have something that's going to add new cross-references, define it as 2.9 before 3.0, so on and so forth, right? And so this matcher is just generally true. I mean, you can make it generally not true, but there's not really a point, because this only dispatches on the document. And so the next thing that you do is this selectors.runner function. And this is where the magic happens, right? This is where you do the processing. So let's see if I can find maybe a simpler example for this. So I haven't published this package yet. At some point today I should do that. But let me see here. I think I had a short-ish build step. Yeah, this is kind of all right. I can probably explain it. Okay, so this is in ohmycards.jl, which is the library I use for those demo cards in Geomarchy, right? And so what this is doing is it moves all of the card meta blocks to the start of the page, because we want to the end of the page, because we want them to be processed by expand templates after all the example blocks have run. So the processing is not. It has a very strict order, right? It goes from the top of the page to the bottom of the page. But you can change the order. You can change the AST as you like. And so this adds a example block if requested in the pipeline, and if you found this adds the cover block and all of that stuff, right? It adds badges to the pages. It could add badges to the pages if we wanted to. I didn't implement that yet. It also adds the page to, it manipulates Documenter's expansion mechanism to say that you should always expand this page first. The reason for that will become clear in a moment, but it's basically because I am also, the way that those gallery blocks are generated, it's not manual, it's actually also just a Documenter block. But in order for that to get generated correctly, you need these card meta blocks to be run first so that it populates the document with that knowledge. That you have certain examples, and this is where they are. So okay, so what are we doing here, right? We've defined this example processing thing, we've defined the order, right? So it runs a bit after doctest, a bit before expand templates. And we've defined this, our own selector function, which just checks, hey, is this element a Markdown code block? Does the card meta, its language, does it start with card meta, right? Is this something that we care about? And so what this is doing, first you get the settings, and the settings are this example config, which is basically just a way for you as the user to pass information to this build stage. And so this just gets put into the plugins keyword argument to make docs. And I'm just iterating over each page, right, in doc.blueprint.pages. This is how you do it. I forgot about that. And so what you do is you say, okay, find all card meta blocks in the page's Markdown AST, right? If the page has a card meta block, is it a known example page? As in this case, I kind of hard-coded that to say that it must occur in an examples directory, but I should probably change that, right? This could be any predicate function you want. You can also set known examples in there. But even if it either has a card meta block or is a known, if it's a known example page, it will generate the card meta block, right? If it's not a known example page, it won't. It will assume that it either should not have a block, or if it should, then one should exist, right? The user should define that. If it's not, then you just skip that page, right? You move on to the next one. Now, this is where the cool stuff happens. If there is a card meta block that was detected, you insert that after the last element in the page. So you've found this block, and you've mutated the AST such that it gets inserted at the end. And the reason this runs at the end is because all of your examples should run before it, right? And if it did not have a card meta block, but you know it's an example page, well, then you generate this AST node, right? And you insert it at the end. And so, yeah, then after this, this is all kind of useless. I mean, this was stuff that I wanted to do, but I never ended up doing. This comment over here. But yeah, so this is the last thing, right? It says, okay, if this is an example page, if the file name is not in doc.user.expand first, we make sure it's there. Oh, thank you. Oh wow, okay, oh my. Okay, so let me sort of speed run this thing. So this is the build stage architecture. This is the plugin architecture, right? You subtype document.plugin to create the info you need. You subtype the Documenter pipeline stage to get a build stage. And then you have a user, if you want to communicate, you just have a user pass an instance of that type. Okay, so let's go back to ohmycards.jl, because there's one more thing there that's pretty cool. Did I lose the window? Oh, interesting. Okay, so if I go to this thing, which is the overview gallery block, what this is doing, or maybe I can show this in Geomarchy actually. Let's see. Examples.md, there you go. So if I look at the code here, you'll notice that there's this overview gallery block. And here I'm just listing out the names of the examples that I wanted to show in this block, right? So it takes these, and it says, okay, so this is an example of the sort of higher level API, the document, right? Like what I showed you was the very low level, you do everything yourself, but you can do what you want. This is the higher level API where you define a documenter matcher, where it will say, hey, is this a code block? Is this not a code block? Does it start with overview gallery, right? And if it does, then Documenter will invoke this runner function. And so what we then do is we say, hey, okay, for page name in every line that's contained within that code block, you obtain the element, right? So you find the page name from the known examples. And this is what I use the plugin for as well. The plugin has a dictionary. And so you store every example in that dictionary. And you get that out here. And then you say, okay, what's the path to this element, right? What's its cover? What's its title? What's its description? And you push this HTML that I generate into, well, that's just pushed into this array for now. But this gets injected into a grid container, and it's got some CSS. And then you set the actual contents of this node. You remove the code block. That's gone. Now it's a raw HTML node that contains this HTML, right? And so of course this only works for the HTML back, as long as you're in some HTML-like backend, right? But you can see how you do this, right? You can see how you say, okay, when I see this block, I want to do this, right? And so this is sort of the core of Documenter extensions everywhere. If I look at DocumenterMermaid.jl, which basically lets you use mermaid diagrams in Documenter, what you can do is something like, let's see. Oh, it's all in here. Wonderful. So they've got this mermaid block, right? And here what they've done is slightly different. They've said, hey, they've overridden the specific function from HTML writer, which I don't recommend you do, but you can if you want, to say, hey, if you are the HTML writer and you see this mermaid block, right, just define a div class equals mermaid and put the code in there. And then for every page that has such a block, it will insert the script that runs and loads the mermaid library. And so this is the build stage that just inserts this mermaid script block onto every page. So this is like a super simple thing that has just been done. One thing I did want to show really quick is the dia documentation that we built out. And so this has a lot of stuff, right? And so one of the things that I did, which is not quite Markdown related, is I figured out how to hack the Documenter nav node system such that you can have a clickable high-level entry. So, and really we need a better API for this in general. But it turns out you can just do this. And so what this is in Documenter normally, you could not click on this and get a separate page, right? This is just a text. But with this, you can inject so this can be a top-level thing, and this could be one of those ohmycards.jl galleries that I showed before. This could be anything. But this comes in quite handy in the diadocs, where you may actually want to click on a higher-level thing. And I don't actually think I ended up using that anywhere here. I did here. So you can click on this, right? And this takes you to a sort of home page. And then this is just an index with a lot more information that gets auto-generated. But then you can also go here, right? And these are subpages which tell you about it. This is in particular a partial sensor. It's the API for a sensor, effectively. So yeah, that's most of what I wanted to cover, I think. Thank you all for listening to this talk. Please descend the ladder of madness. But yeah, thank you.
We have time for questions. Oh no. Thank you.
How much of this is in the Documenter API or is liable to break?
So Morten has assured me that this will not break. That being said, it's not formally API. We both agree that it should be API. And so if people actually want this, then message on the documentation Slack channel that we should have an API for this stuff. And we'll figure that out. But I think in general, this is sort of set, right? Like this has been set since Documenter v0.20 something. I don't think it's changing much. I will say that the Markdown AST stuff is actually a formal API. But the documenter selectors thing is also kind of, set in stone, yeah. I haven't had, for what it's worth, I don't think I've touched that ohmycards package in a year, and I don't think it's had breakage. It's running on the latest Documenter version, it's fine, so yeah.
Any more questions? No.
Hi, a simpler question. So for Documenter, a pet peeve of mine is on the side windows, the quick navigation bars. Is it possible to have number sections? Because right now it's always non-numbered. And I couldn't figure it out.
Do you mean here?
Yeah.
I think you could write a build stage to make them numbered.
Okay.
Automatically. You're asking specifically about automatic numbering, right? Not, not like manually. You can always just do it, right?
Of course, I don't want to do that.
But it's possible through a very similar API to this special page node thing. You just define you define a page node type. You define documenter.walk nav pages on it, which basically just has to recursively go to its child pages, right? And maybe you push some nav node to the internal nav list. This is also in DocumenterPages.jl. It's not that this is like only private code that I cannot show to you. But then what you do is in make.jl, oh, this is the other cool thing I should show off, but later. Somewhere in here, one of these things will be a special page node. You construct a special page node and you pass it to that array. Oh, sorry, no. One of the limitations of Documenter right now is that this pages thing has to be a vector of any. And so you can wrap this all in the special page node. And the special page node can then dictate your behavior and have its own strange child types and whatnot.
Okay, if you have spare time, if you write a tutorial on it, I would be
I should, well, it should be part of the Documenter pages documentation on how it actually works. So at some point that'll go there, yeah.
All right, great, thank you.
Yeah. While you're walking, one thing I did want to say is that you can also choose to not build a document. The way you choose to not build a document is you pass format equals empty array, and you will note the very emphatic note here. And then what you do is you empty the format, you push to the format whatever kind of format you want, right? And in between those, you can edit the AST. So I have one internal side that we use for previews, and then one production side. And I change certain things. I change like the edit link or something, or the GitHub icon between those. And then you call documenter.render, then you deploy docs. Then empty the build folder, empty the doc format, push the new format, call documenter.render, call deploy docs. So this is also a cool thing you can do. Right, sorry, someone had a question.
Yeah, so this might be a little bit out of scope, but I was wondering, like, are there plans to add support for to document other programming languages like MATLAB or Python, similar to like Python Sphinx? Or how would I go about hacking Documenter to make that work?
Yeah. So you could do something like what I did here with this @dyad block, right? Which this is also just executing code. Where did that go? This is also just executing code from a different language, right? And so if you wanted to tie them together, there are ways to do that through Python call, rcall. I don't know if the MATLAB library is still sort of working or not. I don't think the Documenter is ever going to, like, I don't think that the core Documenter developers particularly want to support other languages that well. But if you have a driving use case for it, I will say it's not that hard. So.
I had a practical question, so it may be also beyond the scope of your hacking Documenter. But one of the things, I mean, you have a huge project, right? Diet is an enormous thing. If you change anything, right? So we are struggling also. We have a big project with big documentation, and you change something, right? And you want to run the Documenter itself, or you want to run test suites individually. We always have like multiple environments, and it's just very messy. And often it doesn't work, and the paths don't work. So is there a solution, a simpler solution to run this by hand, run this over the CI? Because it looks so simple. When you do this, it looks so simple, and then when I do it...
Yeah, no, I know exactly what you're saying. So we had a similar issue internally. And the solution to this is you delete everything in the pages. You delete all of these entries. You only put the page that you want to change. And then you say pages only equals true in make docs. And that will stop Documenter from parsing anything that is not in the pages array, which happens to contain only one thing. This is like a very local development solution. For CI, one thing you can do is that I do sometimes do, the Documenter @meta block evals in the main module. And so what you can do is, in every page, you can dynamically add a meta block that checks for the presence of an environment variable. And you can say, I'm just going to write it here. Right? And so you can do that, and that'll automatically be converted to a draft. And in the PR, in your GitHub workflow, you can add certain environment variables depending on the presence of labels. So that's actually what I do for this. The full documentation build takes like 2 hours. On the PR, it takes maybe 1 hour. But I could push that down more, but yeah.
All right, if there are no more questions, we are technically at time. So let's thank all the speakers of the session.